Hi gang, now we're going to review simplifying a radical equation. Alright, so let's start with the one on the screen. Alright, so the first thing you want to do is isolate the radical. Let me just get the light a little bit better than it is at the moment. Okay, the first thing you want to do is isolate the radical. So you want to move this 3 over to the other side. That's a 3, sorry, that came out a little funny looking. Okay, and then once your radical is isolated, you want to then take off the radical so that you can get at the radicand. So to take off the radical, how would you do that? Good, you would square both sides. So to get rid of a square root, you do the opposite, which is to square. So the square and the square root undo each other, they're opposites, which leave you with that. And then then 5 squared is 25. Now I'll just subtract the 3. And we'll get that u is 22. Now it's a good idea to just check that you get an answer, that you get an identity here. So -3 plus it really is more for the quadratic cases, but I'm just going to have you do it here just so you never have a problem. It is possible in a linear case that you can have an error well, I'll get to where you would have an error. Okay, so an identity means you have the same thing equal to the same thing. Just be careful in this section, like if you have something under the radical equal to a negative, don't go any farther because there's no value of x that you could take a square root that would be a negative. Okay, so this would be no solution. This would be no solution. So in a linear case, if you move something to the other side, like this gave me a +5, so I knew I was going to be fine. I just checked it for you guys anyway, because just to get you in the habit for the quadratics. But if you move something to the other side and it added to a negative, there's no solution, because that's an impossible setup. There's no value of x that you would add to 7 and take the square root of that would give you a negative. All right, gang, let's try another one. This is a little more difficult, but the beginning idea is the same. So you're first going to move the 4 to the other side. Okay, so here my square root is isolated. And now I'm going to take off the square root. So I'm going to square both sides. Now this is where you have to be careful because on the left, the square root and the square undo each other. So you're left with 3p plus 10. But on the right, what is this? You have a binomial squared. How do you handle this? Right, this is a FOIL. You have to be really careful you do this correctly. This is a FOIL. First, outside, inside, last. You can't simply just put the 2 in. Okay, so you're going to have to FOIL it. So you can do it in your head if you know the formula. The formula for a plus b quantity squared is a squared plus 2ab plus b squared. You could use that formula or you could work it out if you want. All right, so p times p is p squared. P times 4 is 4p. 4 times p is 4p. 4 times 4 is 16. So you end up getting p squared plus 8p plus 16. Okay, when you FOIL that out. All right, so at this point, what you want to think about is that you're solving a quadratic, okay? And there's a couple ways that we can solve a quadratic, right? We have the factoring, we have completing the square, we have the square root method, and we have the quadratic formula. So we're going to hope that this factors, but if not, we can certainly try other methods. If you're going to factor it, though, it has to be set equal to 0, which means that you need to move these terms to the other side. So I'll move the 3p over, and I'll move the 10 over, so that we have a 0 on this side. Okay, so I'm setting it equal to 0. Now I'm going to go ahead and factor. Okay, it's going to have to be the 3 times 2 because this adds to 5. It can't be the 6 times 1 because that adds to 7. Okay, now if we solve this, so this is a 0 product rule, which means you're going to set each of them equal to 0. Because if something times something equals to 0, either the first thing equals to 0 or the second thing equals to 0. And then we can go ahead and solve this. Okay, now this is where I said you need to go back and check that it works. You can go all the way back to the beginning, but the easiest place to check it is when you have the radical isolated. So like right here, so remember what I said earlier before is that it can't equal a negative. You're just going to check that this radical doesn't equal a negative. Now you can plug everything in if you want, but really it's just this right side. So if I put in, for instance, negative 2 plus 4, this would be a positive 2. You could certainly check both sides if you're more comfortable with that. So if you put in a negative 2 times 3 is negative 6 plus 4. Sorry, I did too much math at once. Negative 6 plus 10, which is then the square root of 4, which is then 2 equals to 2. So you're good there. You can see that you're good there. Negative 3 is also going to work, but I'll show that to you. If you're not sure, just go ahead and check it. Okay, so this is negative 9 plus 10, which is equal to 1. So square root of 1 equals to 1. And the square root of 1 is indeed 1. So again, you've got the identity in both cases, which means they both work. These are both solutions. Okay, I'm just reading this. It says if there's more, not that the first case had that, but if there's more than one solution, separate them with commas. Okay, so you would just like, you would write it in like negative 2 comma negative 3. Okay, gang, that's it on this one. I'll catch you on another one. Bye-bye.